Space is full of scenes that look almost unreal, colors, shapes, and structures formed by physics playing out on an enormous scale. Here are 15 images that reveal just how strange and beautiful the universe can be. From mesmerizing nebulae and swirling galaxies to the intricate details of planets and the explosive brilliance of supernova, each image in this video captures a moment in the vast and mysterious cosmos. For today's video, I'm counting down the 15 most amazing space images. 15. Messier 74. Also known as NGC 628, it was first identified by French astronomer Pierre Méchain in 1780, and Charles Messier subsequently catalogued it in 1781. Positioned about 32 million light-years away from Earth, this spiral galaxy spans about 95,000 light-years in diameter, making it slightly smaller than our own Milky Way. The most detailed images of Messier 74 have been captured by powerful telescopes, with the Hubble Space Telescope providing a particularly notable contribution. In 2013, the Hubble delivered a high-resolution image unveiling the galaxy's grandeur. This image showcases the tightly wound spiral arms, portraying it as a face-on galaxy, allowing astronomers to discern those intricate structures with a clarity they've never could before. Just look at that. The galaxy's appearance is characterized by well-defined spiral arms hosting regions of active star formation. These arms house hot, young blue stars, and they create a visual striking contrast with the older, redder stars concentrated in the central region. Messier 74 has played a vital role in advancing our understanding of galactic evolution. Its classification as a grand design spiral galaxy implies a well-defined and symmetrical spiral structure, providing astronomers with a clear model for studying such galactic formations. The Hubble image, in particular, has enabled scientists to scrutinize the galaxy's features, aiding in the exploration of stellar dynamics and the mechanisms that govern star formation within spiral arms. 14. Neptune's rings. NASA's James Webb Space Telescope has unveiled Neptune in unprecedented detail, marking a significant leap in our understanding of this distant ice giant. This remarkable image showcases Neptune's rings with exceptional clarity, a feat not achieved since NASA's Voyager 2 mission in 1989. Webb's advanced cameras have not only brought the faint, dusty rings into focus, but also captured them in the infrared spectrum for the first time. Heidi Hemmel, a Neptune system expert and interdisciplinary scientist for Webb, emphasized the significance of this achievement, noting the 3-decade gap since the last observation of these faint rings. Webb's unparalleled stability and precision in image quality enabled the detection of these delicate features in close proximity to Neptune. Neptune, discovered in 1846, orbits 30 times farther from the Sun than the Earth, residing in the outer reaches of the solar system where sunlight is significantly diminished. It's classified as an ice giant. Neptune's distinctive blue appearance in visible light, attributed to gaseous methane, is absent in Webb's near-infrared camera images. Instead, the planet appears dark in the near-infrared range, with the methane ice clouds manifesting as bright streaks and spots. The imagery also captures Neptune's dynamic atmosphere, hinting at a global atmospheric circulation that fuels the planet's winds and storms. A continuous band of high-latitude clouds surrounding a previously known vortex at the southern pole is revealed for the first time. 7 of Neptune's 14 known moons also make an appearance in the Webb image, with Triton, the largest and most unusual moon, taking center stage. Triton's frozen surface reflects 70% of the sunlight, outshining Neptune in the image. This moon orbiting in retrograde fashion suggests a possible origin as a captured Kuiper belt object. 13. Tarantula Nebula. The Tarantula Nebula, also known as NGC 2070, stands as one of the most impressive and active star-forming regions in our galactic neighborhood. Located in the Large Magellanic Cloud, a satellite galaxy of the Milky Way, the Tarantula Nebula has been the subject of astronomical fascination since its discovery. French astronomer Nicolas Louis de la Caille first documented the nebula during his expedition to the Cape of Good Hope in the mid-18th century. However, it wasn't until the 20th century that astronomers fully grasped the enormity and complexity of this celestial giant. The Tarantula Nebula got its popular name due to the speedy reappearance of its sprawling filaments and the vast web of energetic stars within. As observational technology advanced, Particularly with the deployment of space telescopes like the Hubble, astronomers gained clearer views of the Tarantula Nebula. Hubble's observations, coupled with other telescopic surveys, provided unprecedented high-resolution images, unraveling the intricate details of the nebula's structure. It spans approximately 1,000 light-years in diameter and is a hotbed of stellar activity. At its heart lies the massive star cluster R136, home to some of the most massive stars known, including several Wolf-Rayet stars, stellar behemoths in advanced stages of evolution. The intense radiation and stellar winds from these massive stars sculpt the surrounding nebula, triggering the birth of new stars. The nebula's appearance is marked by intricate filaments, gas clouds, and dark dust lanes. The vibrant colors seen in images are indicative of ionized gases, with hydrogen glowing in shades of red, sulfur in shades of pink, and oxygen in hues of blue and green. Within the Tarantula Nebula, stellar nurseries give rise to massive stars, some with dozens the times of the mass of our Sun. 12. Antennae Galaxies. The Antennae Galaxies, also known as NGC 4038 and NGC 4039, represent a spectacular cosmic merger caught in the act. These interacting galaxies, located around 45 million light-years away in the Corvus constellation, have fascinated astronomers since their discovery. These galaxies were first observed by astronomer William Herschel in 1785. However, the truth of these galaxies as a collision in progress became apparent much later, thanks to advanced observations and imaging techniques. With the advent of powerful telescopes, such as the Hubble Space Telescope, astronomers have captured stunning images of these galaxies, revealing details of their collision. These galaxies are currently in the process of merging, creating a cosmic dance of stars, gas, and dust. The name antennae aptly describes the long tidal tails extending from the galaxies, resembling the antenna of an insect. These tidal tails are formed as gravitational interactions between the galaxies stretch and distort their structures. Stellar nurseries within these tidal features give rise to new generations of stars. The Antennae Galaxies showcase the violent yet beautiful consequences of galactic collisions. The gravitational forces involved trigger intense star formation as gas clouds collide and compress, leading to the birth of massive star clusters. These clusters illuminate the regions with bright young stars, creating a visually striking display. In addition to the Hubble Space Telescope, other observatories, such as the Chandra X-ray Observatory and ground-based radio telescopes, have contributed to our understanding of these galaxies. These observations have revealed the presence of high-energy phenomena, including X-ray emitting binary star systems, in regions of intense radio emission associated with the galaxy's merging cores. The Antennae Galaxies provide a unique opportunity for astronomers to witness the transformative effects of galactic interactions. As these two galaxies continue on their collision course, they'll eventually merge into a single, larger galaxy. 11. HH 505. Herbig-Haro Object 505, or HH 505, is a captivating and dynamic astronomical phenomenon that provides a unique window into the tumultuous process of star formation. These objects are named after the astronomers George Herbig and Guillermo Haro, who independently studied the peculiar emission line objects associated with young stars in the mid-20th century. HH 505 was likely discovered during systematic surveys of the night sky, aimed at identifying these objects. The celestial entities are typically identified by their narrow, jet-like structures and bright emission lines resulting from the interaction of high-speed material ejected by young stars with the surrounding interstellar medium. The observational history of HH 505 has evolved with advancements in telescope technology. The best and most detailed images of objects like these, including HH 505, have been obtained through space-based observatories like the Hubble Space Telescope. Its high resolution allowed astronomers to capture intricate details of the objects, shedding light on the morphology and underlying physical process. HH 505 is part of a complex interplay of material associated with star formation. It's situated within a molecular cloud or stellar nursery regions of space where gas and dust collapse under their gravitational influence to form new stars. The distinctive appearance of HH 505 is due to the interaction of energetic outflows from a young star within the surrounding gas and dust. The object itself consists of a pair of bright knots connected by a fainter bridge, indicative of a high-velocity jet emanating from a younger stellar object. These jets are often collimated and directed along the axis of rotation of the forming star. They play a critical role in shaping the surrounding environment and influencing subsequent star formation in the region. The sheer size of HH 505 is noteworthy too, spanning several light-years across the cloud. This scale underscores the dynamic and energetic nature of this process associated with young stars. These jets and outflows can travel at speeds of hundreds of miles a second, carving out channels in the surrounding material and contributing to the dispersal of the molecular cloud. 10. V838 Monocerotis. V838 Monocerotis, often abbreviated as V838 Mon, is a stellar variable star located in the constellation Monoceros. Its discovery and subsequent events have made it a celestial object of considerable interest and mystery in the astronomical community. V838 Mon was first catalogued as a variable star by the American astronomer Henry Draper in 1895. However, it gained significant attention and became widely known due to an extraordinary outburst event that happened in January of 2002. During this outburst, V838 Mon temporarily became one of the brightest stars in the Milky Way, reaching an apparent magnitude brighter than any previously known star. This sudden and dramatic increase in brightness puzzled astronomers and triggered intensive observations to unravel the mystery behind this stellar event. The Hubble Space Telescope played a critical role in capturing the evolving stages of V838 Mon during and after its outburst. Hubble's detailed images revealed a series of expanding light echoes, intricate structures formed by the scattering of light from the outburst through surrounding interstellar dust. These echoes provided astronomers with a unique opportunity to study the interstellar medium and the three-dimensional structure of the surrounding material. V838 Mon itself underwent remarkable changes in appearance during the outburst. Initially, it displayed a bright central star surrounded by a series of concentric shells resembling ripples in a pond. The nature of this outburst event remains a subject of ongoing research, with theories ranging from a nova-like explosion to interactions with a companion star or a swallowing of planets. The sheer size of these light echoes observed around V838 Mon highlight the vast distances involved in interstellar space. These echoes expanded over light-years, emphasizing intricate interplays between the star's radiation and the surrounding cosmic environment. And fun fact, the light echoes from V838 Mon provided astronomers with a unique opportunity to indirectly measure the distance to the star. By tracking the expansion of the light echoes, scientists estimated the distance to be approximately 20,000 light-years from Earth. 9. Up close with the Sun. In 2020, the Daniel K. Inouye Solar Telescope in Hawaii unveiled images that revealed solar features as small as 20 miles across, an impressive feat considering the scale of our Sun. With a diameter of 870,000 miles and a distance of 93 million miles from Earth, the solar structures captured by this telescope are comparable in size to the U.S. state of Texas. These structures represent convecting masses of hot, excited gas, or plasma, within the Sun. Situated atop the 3,000-meter-high volcano Haleakala on the Hawaiian island of Maui, the DKIST boasts a 13-foot primary mirror, making it the world's largest solar telescope. This cutting-edge facility is dedicated to studying the Sun's dynamics, aiming to provide new insights to its behavior for improved forecasting of energetic outbursts, commonly known as space weather. The bright centers in the images correspond to rising solar material, while the dark lanes surrounding them depict cooling and sinking plasma. Understanding the Sun's behavior is crucial, as massive emissions of charged particles in magnetic fields can impact Earth, causing damage to satellites, affecting astronauts, and disrupting radio communications. And even scarier, causing power grid failures. Matt Mountain, president of the Association of Universities for Research in Astronomy, emphasized the need for advancements in space weather prediction, stating that while Earth's weaker predictions are highly accurate, space weather forecasting lags behind by at least 50 years. The DKIST aims to bridge this gap by studying the underlying physics of space weather, starting with observations of the Sun. The DKIST also complements the Solar Orbiter Space Observatory, set to launch from Cape Canaveral in Florida. While it will capture images from a record-breaking close distance of just 42 million kilometers from the Sun, DKIST will focus on smaller-scale features and different wavelengths. The collaboration between the DKIST and the SOLO is expected to yield valuable insights into solar phenomenon over the coming decades. 8. NGC 1805. NGC 1805 is an open star cluster, nestled within the Large Magellanic Cloud, which stands as a celestial jewel that glimmers even in the darkest reaches of space. This cluster, part of the vast tapestry of our neighboring galaxy, holds insights into the process of star formation and evolution. The discovery of NGC 1805 is attributed to British astronomer John Herschel, who catalogued it during his comprehensive survey of the southern hemisphere of the sky in the 19th century. The cluster is situated within the LMC, a satellite galaxy to the Milky Way, providing astronomers with the unique vantage point to study stellar populations beyond our immediate galactic vicinity. 1805 is a relatively young, open cluster, featuring a collection of hot, massive stars that illuminate the surrounding region with their intense radiation. The most detailed images of NGC 1805 have been captured by space-based observatories such as the Hubble, which offer unparalleled resolution. Hubble's observations have allowed astronomers to discern individual stars within the cluster and analyze their properties. The appearance of NGC 1805 is characterized by a concentration of bright blue stars, typically young stellar clusters. These massive stars are in the early stages of their life cycles, shining brightly as they convert hydrogen into helium through nuclear fusion. The presence of such luminous stars makes NGC 1805 a visually striking object within the LMC. It also provides a valuable opportunity to study the dynamics of star clusters and the mechanisms governing star formation. The cluster's proximity within the LMC allows for detailed observations of individual stars, enabling astronomers to investigate their characteristics and evolutionary paths. The sheer size of NGC 1805 is pretty impressive, spanning a region of several light-years across. This expansive space is studded with stars of varying masses, ages, and luminosities, contributing to the rich tapestry of stellar diversity within the cluster. 7. Messier 104. Messier 104, commonly known as the Sombrero Galaxy, exists in the constellation Virgo. Its distinct appearance and notable features have rendered it a favorite among astronomers and stargazers alike. Messier 104 was first discovered by French astronomer Pierre Méchain in 1781, and it was later included in Charles Messier's catalogue of celestial objects. The galaxy's nickname, the Sombrero Galaxy, is derived from its striking resemblance to a sombrero hat when viewed on edge. This unique orientation provides astronomers with a clear perspective of its central bulge and sweeping disk. The most detailed images of Messier 104 have been captured by powerful telescopes like the Hubble Space Telescope. Hubble's observations, with its high-resolution capability, have allowed astronomers to explore the details of this galaxy. The appearance of the Sombrero Galaxy is defined by its bright nucleus, surrounded by a thick band of dust that obscures part of the galactic disk. This dusty ring is thought to be the result of a past merger or interaction with a smaller galaxy. The dust lane casts a shadow on the galactic disk, contributing to the galaxy's appearance. The central bulge of Messier 104 is home to an older population of stars, while the disk contains a mix of younger and older stars as well as regions of active star formation. In addition to that unique appearance, Messier 104 has been the focus of astronomical studies to determine its distance from Earth. Measurements using various techniques, including Cepheid variable stars, have provided estimates placing it at a distance of around 29 million light-years. Number 6. The Southern Pinwheel. The Southern Pinwheel Galaxy, scientifically known as Messier 83 or just M83, is a stunning spiral galaxy located in the southern constellation Hydra. It's got a captivating appearance and noteworthy characteristics that make it a prominent subject of observation and study. M83 was first documented by the French astronomer Nicolas Louis Descales during his observations in the mid-18th century. It was later included in Messier's catalogue of celestial objects in 1752. The galaxy's popular name, the Southern Pinwheel, aptly describes that spiral structure when viewed face-on, reminiscent of the rotating arms of a pinwheel. The most detailed images of it have been obtained through the Hubble Space Telescope. Hubble's observations have allowed astronomers to explore intricate details of M83, capturing the spiral arms, stellar populations, and regions of active star formation with remarkable clarity. M83's got a dynamic and vibrant appearance, featuring bright, well-defined spiral arms extending from a central bar structure. Those arms are adorned with regions of intense star formation marked by young, hot, and luminous stars. The presence of pinkish hydrogen gas clouds, a common signature of star-forming regions, further enhances that visual allure of M83. The size of the southern Pinwheel Galaxy is noteworthy too, with a diameter spanning approximately 40,000 light-years. This place is M83 among the larger spiral galaxies in our cosmic neighborhood, and it's relatively close, about 15 million light-years away, and facilitates detailed observations. M83 is part of a galaxy group known as the Centaurus AM83 group, which also includes the famous radio galaxy, Centaurus A. Galaxy groups provide astronomers with opportunities to study gravitational interactions and dynamics between neighboring galaxies. 5. RS Puppis Superstar. The RS Puppis, a pulsating variable star located in the constellation Puppis, has earned its place in astronomical history due to its unique characteristics and intriguing behavior. Discovered by the Danish astronomer Ejner Hertzsprung in 1903, RS Puppis has since become a focal point for researchers seeking to unravel the mysteries of stellar pulsations and the intricate dynamics within these celestial objects. RS Puppis is a type of variable star known as a Cepheid variable, named after the prototype star Delta Cepheid. Cepheid variables are pulsating stars that undergo regular and predictable changes in brightness, directly linked to their intrinsic luminosity. These stars have been crucial in the cosmic distance ladder, allowing astronomers to determine distances to galaxies and measure the expansion of the universe. What sets it apart, though, is its status as a superstar, signifying its extraordinary size and brightness compared to typical variables. It is visually striking, showcasing a luminous and pulsating outer envelope of gas and dust that expands and contracts rhythmically. Its light curve, a graphical representation of its changing brightness over time, exhibits a well-defined pulsation period of approximately 41 days. During each cycle, it undergoes a gradual increase in brightness, followed by a rapid decline, characteristic of Cepheid variables. The star's pulsations are attributed to a delicate balance between gravity and radiation pressure within the outer layers. It is also known for its remarkable regular pulsations, making it an invaluable tool for refining the cosmic distance scale. In terms of composition, like other Cepheid variables, it is primarily composed of hydrogen and helium. The star's outer layers contain elements produced through nucleosynthesis, the process by which stars forge heavier elements from lighter ones during their lifetimes. It is a sizable star, with an estimated radius several hundred times that of our Sun. Its brightness is also comparable, making it visible to observers even with modest telescopes. The star is about 6,500 light-years away from Earth, making it a challenging yet rewarding target for astronomers. 4. The Sharpless 2-106 Nebula. Sharpless 2-106, a striking and intricate nebula located in the constellation Cygnus, is a celestial masterpiece that has captivated astronomers and enthusiasts. This nebula, often referred to as SH2-106, stands out for its structure and interplay of stellar winds, radiation, and dust within its cosmic canvas. The discovery of this one is credited to American astronomer Stuart Sharpless, who compiled the Sharpless catalog of H2 regions of ionized hydrogen in the Milky Way. SH2-106 was designated as Entry 106 in this catalog, highlighting the importance among the vast array of nebula structures. It is characterized by its intricate filaments of ionized gas and dark, obscuring dust lanes. The nebula is shaped by the powerful radiation emitted by a massive young star at its center. One of the distinctive features of it is its hourglass shape. It is created by the interaction of the Wolf-Rayet star's stellar winds with the surrounding material. The nebula is primarily composed of ionized hydrogen gas, with Wolf-Rayet star serving as the dominant source of the radiation. As the star sheds its outer layers through intense stellar winds, these layers collide with the surrounding medium, creating shockwaves and sculpting the nebula. In terms of size, it spans several light-years across, showcasing its vast scale. Its distance from Earth is estimated to be around 2,000 to 4,000 light-years, placing it within the Cygnus OB2 association, a region known for hosting massive young stars. 3. Godzilla Nebula. In the vast expanse of space, an image captured by NASA's Spitzer Space Telescope reveals a scene that could rival the iconic Godzilla. 4 colors, representing different wavelengths of infrared light, paint a mesmerizing picture of a nebula, a cosmic cloud of gas and dust where stars are born and meet their explosive end. The eyes and the snout of the celestial monster emerge as spots near the top of the image. This extraordinary view, processed by Caltech astronomer Robert Hurt, showcases the hidden wonders within the nebula, obscured from visible light by dense dust clouds. Infrared light with wavelengths longer than the human eye can perceive penetrate those cosmic veils, exposing the intricate details. Hurt stumbled upon this Godzilla-like figure while exploring a region of the sky he had browsed many times before. Pareidolia, the human tendency to perceive familiar shapes and random patterns, led him to the eyes and mouth that unmistakably roared Godzilla. And he's not alone. Scientists often spot earthly objects in cosmic images, from spiders to jack-o'-lanterns, in a delightful game of celestial pareidolia. The Spitzer spacecraft, managed by NASA's JPL, ceased operations in January 2020, but its extensive dataset continues to be a treasure trove for scientists. Hurt, however, the cosmic storyteller, seeks compelling images that resonate with the public, whether they depict the birth of stars or a giant monster rampaging through Tokyo. The Godzilla Nebula is situated in the constellation Sagittarius, along the Milky Way's plane, and was part of Spitzer's Glimpse survey, revealing star formation regions within our galaxy. Stars in the upper right, resembling Godzilla's eyes and snout, exist at an unknown distance but within the Milky Way. Meanwhile, the bright region of the lower left, Godzilla's right hand, is known as W33, located about 7,800 light-years away from Earth. 2. NGC 2174. NGC 2174, also known as the Monkey Head Nebula, can be found in the constellation Orion, about 6,400 light-years away from Earth. This celestial masterpiece has garnered attention for its intricate structure and the interplay of stellar winds and ionized gas and dust. Discovered during the late 18th century by renowned astronomer William Herschel, NGC 2174 has since become a notable object of study for astronomers seeking to unravel the mysteries of star formation. This Monkey Head Nebula derives its whimsical moniker from the distinct shape formed by its billowing clouds of gas and dust, resembling the silhouette of a monkey's head and face when viewed in certain wavelengths of light. This playful association adds a touch of charm to the scientific exploration of this intriguing nebula. At the heart of it lies a young and massive star cluster, it's designated NGC 2175, whose intense radiation serves as the primary sculptor of the surrounding nebula. This cluster's massive stars emit powerful stellar winds and ultraviolet radiation, energizing the nebula gas and causing it to fluoresce in brilliant hues. 2174 spans a significant portion of the sky, with an apparent size of about 20 arc-minutes, equivalent to 2/3 the apparent diameter of the Moon. The nebula's composition includes ionized hydrogen gas, which emits a reddish glow due to the recombination of electrons with protons, a process stimulated by the intense radiation from nearby stars. The Monkey Head Nebula is part of the larger HII region, a region of ionized hydrogen. A252, this broader region, encompasses various features, including reflection nebulae, where starlight reflects off grain of dust, and dark nebulae, regions of dense light-blocking dust. Observations of NGC 2174 across multiple wavelengths reveal the dynamic and evolving nature. Telescopes equipped with narrowband filters allow astronomers to isolate specific emissions, providing insights into the distribution of different elements within the nebula. Additionally, infrared observations unveil hidden regions obscured by dust, offering a comprehensive view of the stellar nursery's interior. 1. NGC 7027. NGC 7027, a planetary nebula located in the constellation Cygnus, has captivated astronomers and enthusiasts alike with its unique characteristics and intriguing history. Discovered in 1878 by the astronomer Ernst Wilhelm Leberecht Tempel, this celestial object has since been the focus of numerous studies to unravel its mysteries, as it sits about 3,000 light-years away from Earth. One of the notable aspects is its age, which scientists estimate to be around 600 years. This age determination is based on the observed expansion rate of the nebula's outer shell. While 600 years may seem relatively young in astronomical terms, 7027 offers a unique opportunity to study the late stages of stellar evolution. It's often affectionately referred to as the Jewel Bug Nebula due to its striking appearance that resembles an insect or a cosmic jewel. One more notable aspect is its coloration. The nebula exhibits a combination of hues, including shades of red, green, and blue. These colors are indicative of the presence of different chemical agents in the expelled material. For example, the red hues are often associated with the ionized hydrogen gas, while green and blue hues may be attributed to other elements such as oxygen and nitrogen. The concentric rings observed here are believed to be the result of periodic outbursts from the star. These outbursts expel material into space, creating shells that expand outward over time. The interaction between the expelled material and the radiation from the central star shapes the nebula's intricate structure. Something that sets it apart is that complex structure. The nebula is composed of a central star once similar in mass to our Sun, which has now evolved into a white dwarf surrounded by layers of expelled gas and dust. These layers form that visually striking structure that we see, featuring concentric rings and filamentary structures that have piqued the interest of astronomers aiming to understand the underlying physical processes at play. NGC 7027's dynamic nature is underscored by its ongoing evolution. Observations have indicated that the nebula is expanding and at a rate of about 9 miles a second, contributing to its appearance. The interplay of radiation and expelled material in NGC 7027 offers a valuable glimpse into the intricate dance of cosmic forces shaping planetary nebulae. Each of these views captures only a tiny fragment of the universe, yet together they hint at its astonishing depth and variety. There's always more out there waiting to be seen.